Welcome back. On my last mailbag video, I mentioned that there was a piece that was still on its way and unfortunately wasn't part of the video. Well, this is that piece. What can it be? Well, we're going to open up in just a moment. It's an electronic 4-digit DIY digital LED clock kit, light control temperature temp R7T2. Yes, that's the exact description. Of course, this was bought on eBay. Now this is, I'm assuming, a Chinese seller with an American address in California. The seller is Dodo Tech. I got this for $8.44 free shipping, which is great. And I'm not going to read this exactly word for word here, but see if I get this all in the picture for you. The English, the Chinglish, I should say, on this is really funny. My favorite one is the last line here where it says, with the power cable, it is convenient to be charged. There's no charging to this. They mean it's USB powered, but there's no charging to it. So yeah, basically all this is just a small electronic clock. It runs off a 5-volt. It has a battery backup. It does mention that the backup battery is not included. It is a 1220, a CR1220. That battery ended up costing me $5.99 plus tax at my local, I think I got it at Walgreens. I tried to find it in Rite Aid, they didn't have it, Walgreens had it. You can probably get that other places. I just, I found it quick online and said they carried it, so I just went in there and got it. But if I had more time, I probably could have ordered it and got it a little cheaper, but no worries, no big deal. But considering that the kit itself was $8.44. But all things said, I can understand why they didn't ship it with it, because after all, it is a lithium battery. Now, we do have the usual suspects today. We have the helping hands, of course, a pair of nice little side cutters for cutting the ends of the actual components, a little pair of pliers just in case we need it, my handy Heiko. This is the FX888D, which of course I have set to the 750 degree. That would be degrees Fahrenheit. That's just what it came with shipped, and I happen to like that temperature. And then we have my standard 60-40 solder over here. This is of course rosin core. It's the thin stuff, that's what I like. Inside here of course is a bag, and you can imagine there's bags inside of bags, which is of course packed nicely. It was pretty nice in that little bag. Of course, for free shipping, you can imagine they have to ship it obviously as easy as possible. So we have one bag for the components. We'll get into that in a moment. You can see this is of course the white kit. There are 4 obviously. These are LED segments and they're pretty cool. Now this came in, if I remember correctly, blue, red, green, and white obviously. And I felt, I have enough red and all those other colors of LED all around. I thought white would be kind of cool. So we'll go ahead and start taking the rest of this out. Of course you have, this is actually a little filter screen. This goes on here. These are instructions we'll look at in just a second. This is the little charger lead. Now I'm most likely going to hack the end off of this or get one of these leads with no leads on it. I might even have one. And I'm going to power off my power supply here. It's going to sit in my desk. It's going to be yet another one of those things that's going to be powered off of a common supply here. The rest of the things come out inside here. This does have an acrylic case. These are the pieces for that. You just have to peel off the stuff on here. And of course we have the nice LED readouts here. They're kind of they're not top quality. They'll do the job. One of them here actually has a nick. It's this one here. You could see this in the camera right there. It's kind of a little disappointing, but I think once you have this over the top of it, you're not going to notice it. That's the idea. And you'll just see this once it lights up. So that's that. Here we have the circuit board. And the circuit board's actually really nice. Let's see if I can get a good focus on it here. It is double-sided, and it is silk screened on both sides, as you can see. And one thing they mentioned in the instructions, which I'll show you, is one of the LED components here has to be flipped upside down. You can see this little 8 and then the dot, and you'll see maybe there's another 8. There is another dot here. This one up here, the dot's on the top, and then the one over here, it's backward where it is. And that's just to give you the dot for the colon in the middle. I'm pretty sure. I haven't, obviously seen this thing in operation other than the pictures, and that's what it seems like. Because after all, you could see it here. That's how they did the dot. It looked like a pretty interesting kit. Like I said, it does show the date, the day, the month, you know, the whole 9 yards, the temperature. It does have a light sensor on the top of it, and you know, pretty neat. It does have a battery backup, like I mentioned. That's going to go over here. There's a buzzer. This is where the DC jack goes. There's a controller, and there's actually two. I'll show you those in a second. These are where all the resistors are going to go. There's another bank here. There's 3 transistors, one up here, actually 4, one up here, and then 3 down here. And then there's the 2 buttons on the side, and obviously the LEDs will go on the back, and that's pretty much it. There is a spot over here I was a little confused. There's 5 pins. That's actually, it looks like what could be a USB header. So if you wanted to connect it there, I have to actually look at that. There's no real pin out of what that is. There's also another connector over here, so I'm not really sure what that is either. So we'll have to check those out. There's also a spot over here for a crystal. And that's pretty much it, like I said. Oh yeah, and of course there's the light sensor, and then there's a thermistor, because it also will show the temperature. So that's it for that. Oh, I should also point out there is also a little bag of screws, and that's of course for the case. So we're going to put that to the side because that's way later into this project. Also, I'll keep all these bags out of the way. Should be noted inside the smaller bag, it's a digital clock kit, and it had a little white dot. That must indicate to them for the color, obviously. And let's look at those components. You got your standard. There's a 330 ohm resistors in here. Now these are the ones I know. Well, one of my favorite YouTubers, Big Clive, points out these blue ones are really hard to see the color codes on, and I definitely concur. I like the tan colored resistors much better myself, but I digress. Then the other ones in the bag, if I can make this out correctly, look like they're 10 ohm. I'm not 100% sure. I have to look at it. And then you have your standard buttons, the buzzer, the battery holder. Now incidentally, the pictures I saw online, I had a little bit of a better battery holder. It was actually one of those plasticky ones that the battery clipped into. This is one of the ones that the battery slides underneath, and it's made out of that thin metal, but it should work just fine. And yeah, of course we have those 2 controllers. There's the smaller one is the it's a DS1302, and the other one is an STC chip, and that's a 15W408AS. I did look to both of those up. Before I go too far, there is sockets for each of those. I did look those up, and I did find a nice data sheet for the DS1302, and that's a Trickle-Charge timekeeping chip, which basically means that's the clock. And you know, there's a few pages, 13 pages of this. I just printed out the first page just so we can get some of the specs here. I'm not going to really go over this. If you want to check it out, I'll just put it in the frame for a second. And of course, you can always pause this where you'd like to see it. And I'll put a link in the description below to where I found this particular one. The other chip, however, I couldn't find much information on. Once again, this is exactly what's printed on the chip. I did figure out that this means it's a dip, you know, configuration, which is through hole, and it has 28 pins, which is true. And I did find this, and I'm honestly not 100% sure what all of these mean, but it basically, this is a microcontroller. What this is doing, it's controlling the digits. It's taking the time from this smaller chip and, you know, displaying it on the digits, basically. That's, you know, I'm not going to over glorify. I'm not going to go through all of how it works. You know, like I said, if you want to get a good close look at this and the back side, that's about as much detail as I can give you on it. The rest of this is going to be me soldering this together. So we're just going to go through the components. I'm going to lay them out on the table, get everything organized. The rest of the desk's pretty clean. I already got the iron heated up, like I said. And oh yeah, the instructions. Now they don't actually tell you how to put this together. That's the fun part. Of course, I already looked it over. It's if you've put these kits together before, it's really a piece of cake. If you haven't put this kit together, or any kind of kit together, I do suggest doing another kit first. The one that's a little bit more thorough, at least with good English instructions, if that's your language of choice, obviously. But the reasoning, because this kit's, you know, it's great, but you can follow the parts on the schematic. You know, you can see that this is where the 330 ohm resistors go. That's where the 10K resistors go. This is obviously where the transistors go. But some of the other things are a little ambiguous. They don't really explain what they are. And they tell you to insert the shorter components first, and then the long ones, which is, you know, if you've done these before, that kind of comes naturally. You figure that out on your own as you go. This is the other battery controller, like I was telling you about. And that one is obviously not what it came with. But yeah, there's instructions on here how to set it. We'll look at that later once it's done. But basically, the only thing about how to install it and put it together is up here in this diagram. That's really all you get. And just a little note about, you know, these components here. But really, it's kind of a basic instruction sheet. Again, if you wanna go through all this and read it yourself, you can go ahead and pause it. I don't plan on doing a reading of this. The language in here definitely could use improvement. And the sheet I showed you that I printed up before from eBay was exactly how it was. I didn't actually do any type editing on that. I was thinking about it just so you can understand it a little better, but I mean, really, you know, it's not proper English, I guess you could say, but because of the language barrier, or maybe they had it and it just was automatically translated that way, and I can't fault them for that. But the thing is you could still understand it if you kind of read between the lines. It makes sense after that. But anyway, like I said, I'm going to go ahead and get all these pieces set up and get a little bit of a better camera angle. I might even put the macro lens on. I'm not sure yet, but we'll check that out in just a second. I had somebody comment in one of my videos and asked if I can do a video on how to use a multimeter and how to solder. And I thought that was a great idea. This isn't going to be the video on how to solder though, but I will offer some tips as I go along the way. I do plan on doing a separate video. It's just one of those ones I want to prepare for and make it, you know, as best as possible. But the point of this particular one now is just going to be to build this, and I'm going to do this piece by piece. And I'm going to do them kind of components all at a time. So for example, there's a whole line of 330 resistors that have to go in over here. And I'm going to just put the whole line at once. There's actually 8. And I think that looks like they gave me, they may have given me exactly 8. I may have a couple extras. Sometimes with these strips they do that. The other components, there's exactly how many I need. Like I mentioned, there's a little crystal oscillator here. There's a couple little 22, well, they're probably 22 microfarad. It just says 22. There's a couple of those. And there's one that says 104, so that'd be a 10 with 4 zeros behind it, I believe. I don't really know the coding by head, honestly. I use those, you know, calculators and all that stuff that they have online, and I have one of those little resistor code and one of those sheets around here someplace on my desk. Not sure exactly where it is at moment's reach right now, but I usually grab my tablet or grab my computer. It's just, well, I'm lazy. Short story. But I'm going to go ahead and I'm going to put all the resistors in here, and I'll show you how I do one of those. Basically, I just go ahead and I don't pre-bend the leads. I know a lot of people do that. They also use one of those resistor lead benders, but I kind of just load it in a little angle like this and just push it right down flat. Especially with these kind of cheaper resistors, I guess you could say. The leads are pretty small on them, so you don't have to really worry about them bending too hard. Also, I should note with resistors, if you didn't know, they have to go in either way. I should say there's no polarity on them. If you want to make the circuit look nice, what I do is make all the color bands in the same direction. It doesn't matter which direction, but when they're all lined up the same way, it looks a lot nicer. Some people, I think they like putting like the black strip, the actual first, the first strip, I guess you could say, not the black strip, but the very first one. They actually put that towards like the ground side, or some people put towards the positive. That doesn't really matter. It's not polarity sensitive. The other components here, we have a couple ceramic capacitors. They're not polarity sensitive. The photoresistor isn't. The thermistor isn't. I don't believe the oscillator isn't. It doesn't look like it is, but the actual transistors are, and luckily they all are the same. It's an 8550. So they all go in the same location. You just have to follow the keys, no big deal. So yeah, so I'm gonna just go ahead and follow that procedure. You could solder actually these in from either side really, but I'm gonna solder them from the back. But one of the things I'm gonna do is just hold this real quick and turn it over and just flatten these leads out, fan them out that way. And I do that because it just holds the resistor in place, and then I can just solder it in place. I will do another video on how to solder. I can get up close and do a better video on that particular subject, but I'm going to go ahead right now, put all the resistors in on the 330 ohm and on the 10K ohm. There's all the resistors in, and before I clip the leads, I'll just show you what that looks like. So they were all just bent and outward like that on both sides, and it just went right down one side, and then I went right down the other side, soldered them in. Same thing over here, and did all those resistors at once. That's the nice part about this particular kit. They are all lined up right there like that. One thing I do have to mention with this, you do have to make pretty good contact. A lot of these with the plating on here, you know, it's made for that newer lead-free solder, and I don't really like that stuff. I use the leaded stuff. It works. It's a lot better for the do-it-yourselfer, and you know, you can still use it in a lot of places if you are a DIY person. But you know, businesses, certain ones can't use it, and it kind of sucks. The other stuff melts at a much higher temperature, and it's a lot harder to work with, and I don't really like it. But that's enough about that. The next thing I'm going to do, obviously, after snipping all these leads, is installing the ceramic capacitors, the 22, I'm assuming 22, meaning, like I said before, 22 microfarad. I don't have a capacitor tester, but they're both going to go right here. And then the other one, the one that says 104 on it, that's going to go right here. And that's going to do it for those, and we'll get those in right now. Here's the capacitors in place, leads bent outward on the back, still have to tack them in. I'm going to put the crystal in here while I'm doing this, since it's right there in the vicinity, and it's just a little easier to do it. Now if you look on here, hopefully it translates on the camera, you can see there's little lines on the actual silk screening indicating where the leads go, and they want the crystal to kind of sit just like that. So we're going to bend those leads like that, and I may even hold this in the back and flare those leads out just to get that right where it needs to be. I ended up putting just a little piece of tape on here just to hold that in spot. Now I should mention, soldering these in are actually a lot easier. Sometimes with these components, if the leads are a little bit oxidized, they don't end up taking the solder that well. It's basically, it doesn't transfer heat. The level of oxidation on here doesn't allow the metal to, you know, it does heat up, but not at the best. But these went in a lot better, and you can tell by the actual solder connections. So I'll clip those leads. Next thing we're going to do is I'm going to put the 4 transistors in. Those particular ones, you can see there's a flat on one side here, and it's rounded out in the back, and that's indicative of which direction it goes. Now there's NPN and PNP. I'm not sure which this one is. I'll probably look it up and put it someplace in the video here in the description or in the title or whatever, or not title, you know, somewhere on the screen. But these go in, you can see the flat along the top, and then it's not really rounded, it's kind of, you know, I would say, you know, 4-sided, 3-sided down here. So that just slides in like that. I almost think of these as like Claymore mines for some reason, from like a video game. Metal Gears actually comes to mind. But when I put these in, you can see there are 3 leads, so I'm going to bend 2 one way, 1 the other, just to hold that in, and I'll do that for the other ones as well. Also, I'll get this piece of tape out of the way. Now that they're in, it's time to do the light sensor and the thermistor. Now those have to come out the top of the case. I'll segue over here for a second. Pieces of the case, you can see this is the top, and those are the holes, and these are actually going to pop out. Now I can pop them out all different lengths here, and I'm not sure exactly where this is going to all fit relative. I guess I could kind of line this up real quick. The hole in the back here is where the buzzer sound's going to come through, so that's going to line up there. so it's not going to come out very tall. So I'm assuming I can just go ahead and bend it up a little bit. Now it does have the pattern in the back there, which indicates I could just drop it in there like that, and it does have a clear case, so I don't see why I can't. But you know, the thermistor they had poking up anyway, because I guess that would probably be best to the exposed air. So I will just actually go in here and I'm going to aim that right up just off the side of the board like that. I don't want to really go any higher than that. I suppose I could. I mean, they had it coming completely out the top of the case. I don't really like that look. If I can, I'd rather have it, you know, kind of flush like that. But again, I don't really know how exactly this is going to line up. So I'll just leave it just like that. The thermistor, that has to get bent. I already bent one side of it. You can see it's this little bead right here. That's got to get bent upward, and then this guy's got to come down kind of like that, and then that's going to connect in here just like this. Actually, I'm going to go ahead and get that up there now. That one I may come up just a little bit higher there. I may pull it down just a little bit. We'll see. I really wish I knew how this case was going to line up. I could kind of throw it together real quick, but that'd be going a little further than I'd like to. That might be fine just like that. And I'll get those put in right now. Came across a couple interesting things on here, namely these little points down here, and I'm assuming these are either test points or programming points. And also I mentioned there's the 4-pin header up here and the 2-pin header over here. I did look again on eBay to look at the pictures, and there isn't anything connected there at all. I then broke out the multimeter, and using the continuity meter I tried to pin out the positive and the negative of this whole board here to see if any of those would match up. And right away I came across the second pin in here did connect to the positive rail. The rest of them didn't connect to anything at all, and when I traced out the you know, actual traces here, they just connected to either the well, most of them did, to the main control board up here. So they're doing some kind of function possibly for programming or whatnot. That STC chip is, like I said, a microcontroller, so that's doing all the main work of this actual board. Next thing we're going to do is probably solder in the buttons and the DC jack, the battery holder, all the rest of that stuff. And I'll save the 2 IC chip holders for last on this side. So I'll go ahead and situate all these now. Now these switches here, the little buttons, there are 2 pins, and then there's also 2 prongs, we'll call them, that hold the actual switch in. And you see if I put that in, it kind of holds in on its own. So that's fine. We're just going to do that with both of those. I tend to find that that metal takes a little bit of heat to get that situated, so that might be you know, fun to solder in there. But I'll start with the pins first. In fact, I can even bend these outward a little bit if I want, but they're pretty thick, so they should be pretty good. I did actually flow a little bit of solder on the other side over here, just to give us a little bit of stability. And other than that, that's pretty much all there is for that. The DC jack just slips in, and we'll fold the tabs down. These, again, these are pretty stiff, so we're going to need the little pliers for these. They don't need to be bent a lot, just enough just to give friction on there, just to hold it in place better. That's all we need. And same goes with the Piezo Buzzer. Now this is polarity sensitive. You see there's a little plus in this tab, and tells you to remove seal after washing. I'm not sure what they mean by that. I'm assuming after this goes through the process where they remove the flux from the board, but I'm not sure. Also, we could see that one lead is longer than the other, hopefully. If I can get against a good background here. And one lead is longer than the other. That is the positive lead. And it is marked on the board here which side is positive, so that's going to go in just like that. Again, bend the leads, stiff leads. Resistors and capacitors are easy to do. These other thick ones, you need help. This might be something that I'll hold in from the other side when I do too. The battery holder, there's a little tab in the back here. That's going to face towards the back of the, there it is right there. That's going to face towards the back of the circuit because the open side's where the batteries are going to get slid into. And that's just going to go right over here. You can see there's actually a big pad on the board. That shiny piece right there, that's the positive collector plate, I guess you can call it. And this just sits in there like that. Real basic battery holder. We have to make sure that back tab is against the board so that the battery has clearance to get in there. I could put the battery in now and solder it in place just to make sure it stays in there, but you know, I want to make sure that comes out later when it has to be changed. And that's going to do it for those components. I'm just going to go ahead and, like I said, get those in, and then lastly we'll put the IC chips in. Now we're on to the IC chip holders. Best way to put those in is to slide them in and then bend one pin in each corner outward. The rest can just stay. You don't need to bend them all. And this is keyed. You may see that there's a little rounded edge over here where the other side doesn't have that. The socket does have that same edge here. Maybe against the white background you can see it better, where the other side is flat. So that's it needs to be taken into consideration because the chip also has that same indentation. So that will go here, and then the 8-pin chip will go just right below it here. And obviously the 8-pin chip is feeding into the larger chip. And that's going to do it on this side of the board after these are put in. Everything else is going to happen on the other side of the board now, pretty much. So we'll do that. But like I said, I'm going to hold these in from this side here, come over, and I'm just going to bend one pin down over here, and one pin in the opposite corner on the opposite side, and do that also for the 28-pin connector. And that's just going to hold them in place pretty well. You don't need to go crazy. You can bend every single one, but these are so short. With this longer one, it may be more beneficial to do all 4 corners, just because, like I said, it is so large and you don't want it coming apart. Now they use these so you're not applying heat to the actual chip, and then also if you want to reprogram that chip, I'm sure you can just pop it right out. So those will just get soldered in. Well, that's everything on that side done. Obviously the LED displays are going to mount in from this side and get soldered in from the other side. But before we do that, we want to check everything on here, make sure there's no bridged connections. I'm also going to go ahead and just give this a quick spritz with alcohol and scrub it down with an old toothbrush just to get all the old flux off of here. That's going to just, you know, prolong the life of this. You won't have that stuff sitting on here. They always say it's a good thing to clean that off. They have dedicated flux cleaners too, but I'm just going to use, like I said, some isopropyl. Spray that right on here, scrub it off, no big deal. And we can go ahead and mount the lights, or you know, the displays on top of that. Now I will mention, when you put those in, you want to make sure that all 4 of these little feet you can see here on the edges, those sit in firmly, and also you orient them right. Now they're going to sit, like I said, one like this, one like that, one upside down like that, and then the last one like this. And we'll put them in like that, but first we'll clean the flux. And maybe if I get up close, you can kind of see, especially areas where there's a lot of connections at once. There's a lot of shiny bits. Now, a note about me and kits. I do love putting these things together. I've done quite a few different ones over the years. And I have to say, this one's probably the one with the most solder connections on it at once. Especially a 28-pin chip. All the other ones have either 4-pin chips, or, you know, this is the first one I did with an oscillator, which is kind of neat, or a battery backup for that matter. So this is definitely a fun project so far. I'm having a lot of a good time with it. And that's a lot better. Got it all off. So let's go ahead and put those LED drivers in position. Make sure these are oriented right. I'm going to actually flip this upside down and make sure these are on a flat surface. And then again, we want to make sure all these feet are actually connected to the board around all the sides. And we're going to go solder these pins in straight across both sides. I soldered in each corner on each side of each display, basically, just to hold it in place while I did the rest of them. Makes that, of course, easier to go through the process. And that's going to do it for the soldering portion of this. This went together, like I said, pretty quickly. Only thing left to do on this particular side of the board now, since the front side's done, is just to check over all the LED display points. I think there's, let's see, 1, 2, 3, 4, 5 for each side. And then there's obviously 2 sides, so there's a lot of points to go through, but I'll just run through this real quick. And also I'll do the same thing like I did on the other side with the flux, and I'll just remove that real quick. Now I'm not going to crop the leads on this side. I decided not to do that because if I ever have to get this off, it'd be a lot easier to realign them with them out. And I also didn't bend them at all. I found I didn't need it since I was up against the surface, and that's just why I did that. But I will, of course, like I said, clean those up, check everything over before I actually put the IC chips in here, because that's going to be the next thing to do. All right, let's get these chips installed. As I mentioned before, they are keyed. You can see there's a little key in this side, there's a key in this side. It's just a little scalloped out edge, and that will matter where they go. So we can go ahead and put them in here. Now on these chips, I should mention, the pins are kind of flared outward a little bit. What you want to do is put it up against the surface like this, and you're going to rock it. Let me get a little closer, zoom in on that. You can see how those pins are slightly splayed outwards. So I'm just going to take this chip, and hopefully I can show this because it's kind of tiny. I'm going to rock it downward onto those pins just a little bit, and flip it over and do the same thing on the other side. And the point is to get those to kind of line up a little better. See, they're not splayed outward so much, they're kind of inward more. And we'll do that on both chips, and then once we have that done, we can insert it directly into these sockets. And you want to make sure you just kind of teeter it in a little bit. You have to have a feel for it. They go straight in, but you know, those pins are delicate, you don't want to bend them. And again, mind that actual little cutout in here. Sorry for being off camera. Mind that little cutout right here, because that's what's going to actually indicate the keying of this. You don't want to put it in backwards, you could fry the thing. So we'll get the 28 pin put in next. That chip was probably the hardest thing I had to put in this particular build. And it wasn't like super duper difficult, it was just the hardest thing. Everything else went together fairly easy. That just had a little bit of finessing to put in. But that's it, all the components are completely put in. We do have to connect the battery, and then we can plug it in and test to see if it works. The battery, like I mentioned, is just a standard, you know, one of these round button cell batteries. It's a lithium 3-volt. It's a 1220. I'm just going to go ahead and pop that out. If I remember correctly, the positive side face down. We have to double check that. It's kind of ambiguous. Usually with this, the positive side's up. So I'm going to go ahead and just go that route, because I'm pretty sure that's right. And the moment of truth comes in plugging it in and seeing if this thing powers up or goes bang. Well, it does say something. $185. Now I have to look at the manual here and see exactly what they tell you to do. We'll probably set everything first, and then we'll build the case next. Let me pull that book out and see if I can interpret the Chinglies on it. Oh, that looks a lot better, for sure. A little shiny, but it looks good. Now the case is pretty straightforward. There's a top, a bottom, sides, and a front and a back, and with all the screws and the little nuts. Now, you can kind of take a guess to which side is which based upon how the piece looks. But like I said, there weren't any instructions on how to put this together, so I kind of had to figure this out. This is actually the front, and the reason why I know that is because this is the bottom edge that faces you, because it puts it on a little bit of an angle. And we can see this is actually the back plate, and they line up to an extent. These things are also keyed. Some have 3 and some have 2. And also the little holes like up here and down here, those are where the screws are going to go through. And this little cross shape here, this is where the nut and bolt's going to sit into. Also, this is the side where the buttons are. This is the side where the power plug is. And the thermistor and the light sensor come out the top on this, and this would make this the bottom. So basically this is going to go in the front like here. The bottom is going to go like this. You can see it just slides into these little pieces like that. The back will go on, minding where the hole is for the buzzer, so that'll go like that. Then the side with the buttons over here will go in like so. This piece over here will line up with the charging port, as they said, which of course it's not. And then the last piece to go on will be the top with that thermistor that pops through. And we want to orient that right, of course. And that's going to be the whole thing, just like that. And then of course we'll have to take off all this brown protective paper before we actually attach it. The pieces on the top poke out, you know, pretty well, or I should say they stand proud fairly well. And the way this works is, as you can kind of imagine, the nut is going to go into here, and then the bolt's going to come in through the front and engage the nut, and kind of these two pieces here, those two little faces, or what's going to hold this together from the back. So we'll probably, judging by where that is and where the side one is, so we'll probably connect the back here and here first, and then the sides to the top plate up here next, and then we'll get the front faceplate on last, as I think the course of action we're going to take. I'll have to get my small Phillips head screwdriver out. I don't think I want to put a nut on, you know, a wrench or anything on here, because I don't want to tighten it too much where it will crack. And of course I'll peel off all the paper. The way to do this is to lay the back and the bottom down, put the nut in, which becomes captive inside there, and then use a screwdriver and just gently tighten it in until it goes, obviously. I mentioned using a wrench, or yeah, you can't. Now the thing about this is you have to be careful, because if you don't tighten it just right, this can slide in and out, because you're just holding it in like that. But that's what we're going for. And I tell you, whoever engineered this engineered it pretty well, because maybe you can flip it around and you can see it better. That goes pretty close to the edge right there, which is pretty good. So that's just one of, you know, quite a few different screws we're going to put into this thing. But you can get an idea. That's, like I said, the back. So this will set in like this. And yeah, that lines up kind of close, but not exactly. You can see it's a little off. These are probably cut with a laser cutter, and I was actually sitting here while I had the camera paused and said, God, for $8, you can't get the components in this kit alone for $8. I don't think. Pretty cheap. Well, you can see I got the front, a side, a back, and a bottom on, and these are actually two separate halves here. They're not connected to each other yet. We're going to take the top piece here, the actual circuit, bring that in so we can put the side piece on, because these buttons do stick out the side over here. We'll put the next nut in on that side, and then I can put the top on as well, and this will solidify the whole case. And that's basically it for this build. The case went together fairly easily. There are some spots I would like to see a little bit more of a better detail, I guess you could say. For example, if you look at it from the top, you're not going to pick it up now, but there's, like I said, there's little keys that kind of fit together, and these edges here and the fact that there's 2 screws is great. The bottom half, you could see it's held in by the front here in these 3 spots, and it's keyed in the side, but there's only 1 screw here, and there's no like keying on this side or this side. I would have liked to have seen that, considering there's a key here and there's a screw here. That's just the 1 spot. So you can see one spot here, the corner is a little loose. Other than that, if this was attached a little differently, but given the way the pieces were cut, and I'm sure they were all cut out of a piece that was all, you know, pretty close together, I could see why they didn't do that. And you can see it's a lot clearer since I put that film on there. The numbers don't stand out as much. You know, the segments that are off, and also when it shuts off, you don't see anything at all, which is really nice. So yeah, this was a fun build. I recommend doing it. But I only recommend doing it if you've already soldered a kit together. And I don't think it makes a good beginner's kit. You can see there is quite a bit to solder on the back there. One thing you can see, the hole for the buzzer isn't exactly lined up with the case, but I'm sure you'll hear it through there, no problem. You know, not a big deal. Getting the battery out, of course, to change it is going to be an issue. But then again, the shelf life in those is 8 years when it's not powering anything, and I'm kind of under the influence here that when I connect this up, that battery's really not connected to anything, and maybe doing that through the processor, I'm not sure. But when you disconnect this, it does retain the setting, which is great. But how often will you go without power? But yeah, I'm gonna get this mounted over here someplace, or maybe I might even keep it right here next to the Arduino or something, but I do intend on keeping it living on this particular desk over here, because it's just, you know, part of the Pileggi Technical Services backdrop here. And I guess at that point you guys will always know what time I'm filming my videos, as long as it's in frame, so that's always a quick fun fact to see at the time of watching the video. Well, anyway, that's all I really want to do with this particular video, which is quite a bit, the building of it, and walking through what the components were for the most part. And stay tuned for that video where I do all the programming on it. Modding on this thing, I'm wondering if we can maybe put some LED lights in the back of this thing to make it glow. I've thought about it. I'm not really sure where I would tap them off of. I did mention that those pins up there at the top and the other ones, one of them did have a connection to the negative, but I'm not sure where we would connect those two, but it would be kind of neat. Not sure what purpose it would serve, but again, we can do it, so why not? Now this one right now seems like it's scrolling through the different modes. We can see it's showing the time, and then automatically goes into the next one. I didn't test to see what the light sensor does. I'm assuming that it may or may not make the alarm come on or not. It was one of those things. I was assuming it was going to make the display brighter or not, but it doesn't seem to be the case. Another thing I'll quickly point out before I go, the one LED that had the damage on it ended up being the second one in, and the reason why I could tell is because that film ended up sticking so well, it actually stuck to the concave section there, so I can see it. Not sure if you could see it on camera or not. You can see the lines in between where the reflection shines off it, but I can see it. All in all, it's a neat kit. I would build it again. It's actually a neat little project. I was actually thinking of finding a way to connect it to one of my buck converters and actually hooking it up to let's say a 9-volt battery, and setting the buck converter to 5 volts obviously, And you can actually run this thing on that kind of setup for a very long time, because the one system I would use is the buck boost converter. So as the battery drops below that 5-volt setting, it's still going to operate, believe it or not. I think all the way down to 3 volts and something, 3 point something volts, I should say. And that's pretty neat. You can actually get that to go for a very long time, and I'm sure it doesn't draw very much current, so that battery would last for a long time anyway. But anyway, I want to thank you for watching. I know it's been a long video, but I haven't done one of these builds in a while. It's always fun doing it. I also want to say stay tuned for a video on how to solder and how to use the multimeter as has been suggested. I didn't really want to do a whole lot of the soldering thing in this particular video, because I knew it was going to be long enough trying to build the kit. And I want to concentrate the how to solder video just specifically on actually how to solder. And you know, it's just the technique that I use. But anyway, thanks for watching. We'll see you next video.